Welcome to the MJ School of Mining and Geology, where the mysteries of the Earth's crust are unveiled, and the secrets of mineral extraction are revealed. In today's lesson, we embark on a journey into the fascinating world of comminution, a fundamental process in geology that lies at the heart of mineral extraction. Please like, share, comment and subscribe. Comminution is the process of reducing the size of solid particles or chunks of material. It is a crucial step in various industries, including mining, mineral processing, pharmaceuticals, and food processing. In mining and mineral processing, comminution is particularly important for liberating valuable minerals from their host rock. Safety measures are paramount in any industrial process, including comminution, to protect workers and minimize the risk of accidents. Workers should wear appropriate PPE, including safety glasses, ear protection, gloves, and steel-toed boots. Respiratory protection may be necessary when handling dusty materials or operating equipment in enclosed spaces. Ensure that all comminution equipment is properly guarded to prevent contact with moving parts such as crushers, mills, and conveyors. Install safety guards, interlocks, and emergency stop switches to protect workers from accidental contact with machinery. Implement dust control measures, such as ventilation systems, dust collectors, and water sprays, to minimize the generation and spread of airborne dust during comminution operations. Labeling samples allows for easy identification and tracking throughout the comminution process. Each sample may have unique characteristics or origins that need to be documented for further analysis and interpretation. Proper labeling helps ensure that the correct samples are processed and analyzed. It helps prevent mix-ups or errors in sample handling, which could lead to inaccurate results or data loss. By labeling samples, researchers can trace the entire history of a sample, from its collection in the field to its processing and analysis in the laboratory. This traceability is crucial for maintaining data integrity and quality assurance. Crushing is the initial stage of comminution and involves breaking large chunks of material into smaller pieces. It is usually accomplished using mechanical equipment such as jaw crushers, gyratory crushers, or impact crushers. First step is switching the crusher on. After turning the crusher on, it produces a light sound to show no sample is inside. As it turns, the material is fed into the crusher, where it is subjected to compressive forces that break it apart into smaller fragments. But, after putting the sample in, the machine makes a loud sound due to compressive forces. When the crusher is done crushing, the machine goes back to light sound. Then you can switch off the machine and collect your primarily crushed samples. Grinding is the process of further reducing the size of the crushed material to finer particles. It is typically achieved by rotating a cylindrical or conical mill containing grinding media such as steel balls or rods. Pulverization using ring pods is a specific method of comminution that involves crushing and grinding solid materials using a specialized type of pulverizing equipment known as a ring and puck mill or ring and roller mill. This method is commonly used in laboratories and research facilities for sample preparation in geological, metallurgical, and material science applications. A ring and puck mill consists of a stationary grinding ring, or bowl, and a rotating puck, or roller, positioned inside the ring. The ring and puck are typically made of hardened steel or tungsten carbide to withstand the high-stress conditions of comminution. The solid material to be pulverized is loaded into the grinding ring, usually in the form of coarse particles or small chunks. The sample may be a geological sample, or material sample that requires size reduction for analysis or further processing. Once the sample is loaded into the grinding ring, the puck is rotated at high speed, typically several hundred RPM, while simultaneously applying downward pressure on the sample. The rotating puck exerts crushing and grinding forces on the sample as it moves across the bottom of the grinding ring. This action effectively crushes and grinds the sample against the stationary grinding ring, reducing it to fine particles or powders. After placing the ring pod, turn the knob into clamp side to ensure there is a pressure applied. The combination of impact, compression, and shear forces exerted by the rotating puck and the grinding ring results in size reduction of the sample. Time can be around 4 minutes or it can be 5 minutes. Then turn the machine on so that the process begins. After 4 minutes the sample would have been pulverized into a powder. The pod is collected and be placed somewhere away from water or any contaminants. However, you must clean and spray the tray to avoid contamination. The powder is then safely placed into a tray that will easily allow the packaging into sample bag. The powder is then stored into the labeled bag, same in labeling as the initial core sample. The bagged powder is stored in certain order. You then have to clean the ring pods by pouring the plate and sand into the pod and pour the water. Put the ring pod back under pressure. This time set 2 minutes. After 2 minutes you will see the slurry inside the pod. Clean the ring pod with water, then wipe it and spray it to make sure there is no contamination that will tamper with the results and analysis. This will then bring us to the end of the process. After pulverization is complete, the pulverized sample is collected from the grinding ring for further analysis or processing. The sample may be sieved or separated to remove oversized or undersized particles, depending on the application. In conclusion, the comminution process serves as the cornerstone of sample preparation in geology, unlocking the hidden secrets of Earth's composition with each finely crushed particle. Through the relentless action of crushers, mills, and pulverizers, solid materials are transformed from rugged chunks into meticulously sized fragments, ready for analysis and interpretation. Please like, share, and subscribe to keep up with our content.